In this video, I will show you how to prove that two triangles are similar. Now, this is just an introductory video, so these problems are going to be very basic and very simple. The more advanced problems will come in a later video.
Let's look back for 1 second. There are three different ways to prove that two triangles are similar. One is side-side-side similarity. If all three pairs of sides are proportional, that just means they're going to all make the same ratio if I make fractions out of them. For example, 10 over 5, 10 and 5 are corresponding sides, and if I do 10 over 5 as a ratio, I get 2. 6 and 3 are corresponding sides, and if I do 6 over 3, I get 2. 12 and 6 are corresponding sides. If I do 12 over 6, I get 2. So this is what it means when I say all three pairs of sides need to be proportional. So that would be side-side-side similarity. By the way, these three ratios that all turn out to be the same, this is called the scale factor. So we would say the scale factor is 2. Alright, and in this context that means that the big triangle is twice as big as the small triangle. Anyway, in addition to side-side-side similarity, we can prove that two triangles are similar if they have two angles that are the same. Like 65 and 30, the small triangle has degrees 65 and 30. That's enough to prove that these two triangles are similar. And the third and final way to prove that two triangles are similar is side-angle-side similarity. The S and S again refer to the sides being proportional. So I mean, I used the same number, so we've already done the math, but these are still proportional, meaning that the 10 over 5 equals 2 in the same way that if we've got the 12 and the 6, again 12 over 6 equals 2. So we have two pairs of sides that are proportional, and then one angle that is congruent. It's important that the angle that is congruent is between the sides that are proportional. So that gives us our side, angle, side. If this 30 degrees in here were somehow on a different angle, so if I took this 30 degrees and put it over here, for example, these two triangles would not be similar. Even though I have two sides and an angle, and here I have proportional two sides and an angle, it's the wrong angle. Okay, even if the 30 on this triangle were also moved. Okay, even if this 30 were also over here. Still, these two triangles are not similar. We cannot be sure that they are similar. Okay, it has to be two proportional sides and the angle that's between them, not the angle that's off to the side. Okay, so that's the background.
So looking at problem number 1, is there enough information to say that these two triangles are similar? Well, I see that they have two angles that are congruent, so they will be similar by the angle similarity postulate. And if that's the case, angle A is going to correspond to angle F. Angle B is going to correspond to angle L. They're both 40 degrees. And that leaves angle G. Now, there is a such thing as a side-angle-side similarity postulate. However, we can't just assume that the corresponding sides are proportional. We have to check. So I see side angle side, but we have to go ahead and do, for example, 12 over 9, because those would be corresponding sides, and see if that really equals 8 over 6. Now, both of these are divisible by 3, so that's going to be 4 over 3. Both of these are divisible by 2, and that's going to be 4 over 3. So that means the corresponding sides are proportional, so these will be similar by the side angle side similarity postulate. All right, now with that in mind, that means that angle L is going to correspond with angle T. So I'll put that first. Okay. Angle M corresponds with angle S. And that leaves angle U. So the order is very important. Now, we only have the three methods of proving that triangles are congruent. We have the angle-angle similarity postulate, the side-angle-side. The only other one is the side-side-side similarity postulate. But for that, we need 3 pairs of proportional sides. And we only have 2 pairs of sides at all. So this is going to be a no, which makes me realize I should have circled yes on the other 2. So this is going to be a no because we only have 2 pairs of proportional sides. We don't have 3. All right, be careful to leave these 2 positions blank. Some students will say, no, we don't have enough information, but then they'll still try to say triangle WYZ is similar to triangle MSK. That doesn't make any sense. If they're not similar, don't make a similarity statement or you will lose points. So on problem number 4, the additional information we have is we got these parallel lines. And parallel lines lead often to congruent angles. These are alternate interior angles, and when the lines are parallel, those are going to be congruent. And similarly, these are also alternate interior angles, so those will be congruent. So right there, that is enough for us to say that these triangles will be similar by the angle-angle similarity postulate. And let's see, angle J corresponds with angle E. Angle F is going to correspond with angle F. And that just leaves angle D. All right, what about number 5? We don't have parallel lines this time, but they just went ahead and gave us that these 2 angles are congruent. But in addition to that, we also know that this angle will be congruent to this angle because they are vertical angles. That gives us 2 pairs of corresponding angles that are congruent. And that is enough. Again, by the angle-angle similarity postulate, all you need is 2 angles. So let's see. Angle A corresponds with angle A. Angle B corresponds with angle D. And that just leaves angle E. Okay. Now, I see that we have all 3 sides for both triangles. So there's a chance that this is going to be side-side-side similarity. We cannot assume that it's side-side-side similarity just because all the sides are labeled. We have to check the ratios and see. Now, there's something else that you want to keep track of because the triangles can be rotated in all kinds of different ways. So the corresponding sides should be the biggest for both triangles would be corresponding. So for example, in the first triangle, 4 is the biggest. And in the other triangle, 8 is the biggest. So if these are similar, those would be corresponding. So if I do 8 over 4, that simplifies down to 2. Okay, now the smallest side of the first triangle is 2. The smallest side of the last triangle is 4. So if these are similar, those will be the corresponding sides. And again, I'm going to do this triangle on the right. I'm considering this to be old and this to be new. So in my mind, I'm thinking new over old. All right, because that's how you do a scale factor. So 4 over 2. And that's going to be 2. So it's looking good so far. And then that just leaves the 6 and the 3 to be corresponding. And of course, that also makes 2. So we do have 3 pairs of sides that are proportional. So these will be similar by the side, side, side similarity postulate. And now, so the order of the letters. Angle R is going to correspond with angle Y. Then we have angle S. Notice how angle S is between the triangle and the circle. That would be angle Z between the triangle and the circle. So that's another reason to label these like I did. All right, so I've got Y, Z, that just leaves X. The order matters. All right, for number 7, all right, I see a bunch of sides over here, but over here I only have one side that's given, so that's not going to do anything for me. So I'm ignoring the numbers on the sides now. So angles. I see one angle that's marked congruent for both triangles. But also, in addition to that, I know that this angle is going to be congruent to this angle because they are vertical angles. And that is actually enough information to prove that these two triangles are similar because of the angle-angle similarity postulate. Okay, and then angle A is going to correspond with angle A. Angle B is going to correspond with angle D. And angle C is going to correspond with angle E. Now, if you can prove that the triangles are similar, you're supposed to go ahead and find the values of each variable. So, for example, if I want to find x, x corresponds with the 15. So I can begin to write my equation by doing either x over 15 or 15 over x. All right, so for example, I could say x over 15 equals. And then the 4 and the 12 are corresponding. So I could do 4 over 12. And I could solve this. So first I would reduce. So this reduces down to 1/3. And then I would cross multiply. So that will give me 3x is equal to 15. And then if I divide both sides by 3, that gives me x is equal to 5. Now, I'm switching colors. Now I'm going to find y. So we'll do the same type of thing. Y corresponds with 10. So I could do y over 10 equals. And I could still use my 4 over 12 again, which would reduce down to 1/3. And then if I cross multiply, that's going to give me 3y is equal to 10. So if I divide both sides by 3, that tells me that y is equal to 10 over 3. And we'll just leave it like that because as a decimal, it would be a decimal that that never ends. So, for example, if I do 10 divided by 3, see how that goes off the screen? So I'd have to round this, and that's not allowed. Okay, how about this next one? Of course, we're looking at the small triangle and then the bigger triangle. Now, I see that they have these two angles marked congruent. So that makes me look out for angle-angle similarity again. Now, this angle right here is shared by both triangles. Okay, if I were to draw this picture with the triangles separately, okay, if I were to draw, the small triangle, and then later I were to come along and draw the bigger triangle, okay, this would be angle A for both triangles. So I would have angle A right here, and then I'd have angle A right here as well. So that means we have two angles that are congruent. In fact, you know what? Maybe I should keep going and label these. Okay, so now I've drawn them separately so you can really see what's happening. Notice that I have two pairs of angles that are congruent. So they will be similar by the angle-angle similarity postulate. Now, to get the corresponding angles right, I have to be very careful to look at the markings that I have. So angle A will definitely correspond to angle A. Looking at the markings, that would be true. So triangle A. Now, angle B is going to correspond with angle D. All right, so don't just go, oh, angle B seems to be about in the same spot as angle C. No, you have to use the markings. So B and D are congruent, so D comes next. Okay, and so angle E is actually congruent to angle C. See how they're both blank? Wait, so ABE, so I'm supposed to say angle C right now. But then it says, if you can prove they are similar, find the value for each variable. So I need to keep going and find out what x is and what y is. So I think it's very helpful that we drew the triangle separately. I think that's a great idea. So let's use these diagrams. So the small triangle, I have a 4, a 3, and an x. All right, so I have a 4, I have a 3, and I have an x. Now, for the large triangle, okay, the side AD, that's going to be 10, all right, 6 plus 4. So this will be 10. All right, side DC is simply 6. What about side AC? That's going to be x plus y. Interesting. All right, I think we better find x first, and then we'll find y later. Okay, so if I want to find x, okay, you have to remember that AB and AD are the corresponding sides. It's tempting to match up the x with the x plus y, but that's false. AB corresponds to AD. So x corresponds to 10. Okay, so for example, since x corresponds to 10, I can do x over 10 equals. All right, now I need another pair of corresponding sides. For example, let's say if I do the 3. All right, what does the 3 correspond with? All right, BE corresponds with DC. So the 3 corresponds with the 6. So let's solve this. So this will be x over 10 is equal to 1/2. And if I cross multiply, that's going to give me 2x is equal to 10. And if I divide both sides by 2, I find that x is equal to 5. So next I need to find y. The only place I see y is right here in this expression. This is side AC. So let's think about what corresponds with AC. So AC corresponds with AB. Okay, so this is AC. Wait, I said that wrong. AC corresponds with AE. So here's AC, and this is AE. So those two are corresponding. Okay, while we're looking at this, let's go ahead and identify the other pair. Remember last time we did BE and DC. So here's BE and here's DC. So those are the corresponding sides. So if I do it in the same direction as that I did last time, I will have 4 over x plus y equals, and then I will have 3 over 6. So I'm going to do two things right now. 3 over 6 reduces to 1/2. But also, we know what x is. We already found that x is equal to 5. So instead of putting x plus y, I'm going to put 5 plus y. And then we would cross multiply from there. So if I do 1 times 5 plus y, that will just be 5 plus y. And 2 times 4 is 8. So then if you subtract 5 from both sides, you get y equals 3. Okay, do we have enough info to show that these triangles are similar? Yes, we do, because we have these angles that are congruent, and we have the shared angle. All right, angle C is going to be the same for both triangles. So that's 2 pairs of angles. In fact, I think I'm going to draw these triangles separately. All right, so as you can see, I have 2 pairs of congruent angles. So the triangles will be similar by the angle similarity postulate. And triangle ABC, A corresponds with D, B corresponds with E, and angle C corresponds with angle C. All right, since they are similar, I need to go ahead and find the value of each variable. So let's go ahead and label these pictures. So on the small triangle, this is 15, and this is 10, and this is y. Now on the large triangle, at the bottom here I have 52, and then side AC, well that's 24 plus 15, so that's going to be 39. And for CB, I still need to add these. It's not going to be 10x, I get that a lot. It's going to be 10 plus x, or I like to say x plus 10. So now we will just do new over old equals new over old. Considering this one to be new and this one to be old for this problem. It doesn't really matter which one you pick to be new and which one you designate to be old. Okay, so new over old. So for, if I want to find x, I can do x plus 10 over 10. Those are corresponding. Now for my next pair, I need all numbers. So I'm going to do 39 over 15. Okay, both of these are divisible by 3. So I am going to go ahead and reduce this. So this is going to be 13, and this is 5. So time to cross multiply. So I have to do 5 times x plus 10 is equal to 130. So distributing, I get 5x plus 50 equals 130. So that's going to give me 5x is equal to 80 once I subtract 50 from both sides. And then I'm dividing both sides by 5. So that's 16. So x turns out to be 16. Now, what about y? So y corresponds with 52. So I'm going to do new over old again. So I'm going to do 52 over y equals, and I can again do 39 over 10. Okay, so 52 over y. We already saw that this reduces down to 13 over 5. So if I cross multiply, I will have 13y. Okay, and now 5 times 52. That's 260. So then I simply divide both sides by 13. And that's 20. So y is equal to 20. For these last few problems, we are to determine whether each statement is true or false. If it's false, we have to explain why. If the measures of the sides of one triangle are 5 times the measures of the sides of a second triangle, then the two triangles are similar. So, for example, say if we have a small triangle that has sides 1, 2, and 3. So if one triangle has the measures that are 5 times another triangle, so this would be 5 and 10 and 15. Would these triangles be similar? Yes. These would be similar because they're basically describing side-side similarity. Because we multiplied all the sides by 5, that guarantees that we have a scale factor of 5. You know what I mean? If I did new over old, if I do 10 over 2, or if I do 5 over 1, or if I do 15 over 3, in every case, I'm going to get 5, of course. So they're all proportional. That's side-side similarity. So that's why the answer is yes. If the lengths of the sides of one triangle are half as long as the sides of a second triangle, then the two triangles are similar. All right, well, this is basically the same thing. All right, this is going to be yes again for the exact same reason. All right, let's draw the picture again. If the lengths of one triangle, they're half as long as the second triangle. So let's start with the second triangle. All right, let's say this is 4 and 6 and 8. All right, so if we have a triangle where the sides are all half as big, then this would be 2, and this would be 3, and this would be 4. But again, they are basically describing side, side, side similarity again. If I did the scale factors, all right, you know, if I did new over old, that would be 3 over 6. That's 1/2. If I do 2 over 4, again, that's 1/2. If I do 4 over 8, again, that is 1/2. So the sides are proportional, side, side, side similarity. So yes, they are similar. If two triangles share one angle in common, and then the triangles are similar. One angle in common, that's not enough. All right, we need two congruent angles. So we can do angle similarity. All right, having one angle in common is not enough. You need two angles to be similar, two angles to be congruent. Number 13, if the side lengths of a triangle are each 3 inches more than the side lengths of a second triangle, then the triangles are similar. This is going to be a no. The sides are not proportional. But let's show some work on this. So let's say you have one triangle that is 1, 2, 3. And then you have another triangle where each of the sides are 3 inches more. Okay, so if I add 3 to all these, this would be 4, 5, and 6. So the question is, are these similar? So if I do new over old, that's going to give me 5 over 2 and 4 over 1 and 6 over 3. So to have side, side, side similarity, all of these sides need to be proportional. In other words, all of these fractions have to give me the same scale factor. 5 over 2 as a decimal, that would be 2.5. 4 over 1 is just 4. All right, those are not equal. 6 over 3 is 2. All right, these are not equal. All three of these would have to be the same if the triangles were similar. And they're not. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.